A mason is laying bricks for a narrow staircase. For every step, he needs to add 4 bricks to the previous step. The staircase requires 25 steps. If you were to order the bricks for the mason, how would you determine the total number of bricks required for the staircase? In this lesson, you will learn how to calculate the sum of n terms in an AP. At the end of the lesson, you will be able to derive the formula for the sum of n terms in an arithmetic progression, also called AP. Apply the formula to calculate the sum of n terms in a given problem. APs display an interesting property that can help us derive a generic formula for calculating the sum of n terms. Take an example of a sequence of numbers 2, 4, 6, 8, 10, and 12. If you add the first term 2 to the last term 12 in the sequence, the sum of the two terms equals 14. Similarly, if you add the second term to the fifth term and the third term to the fourth term, you get 4 plus 10 equals 14. 6 plus 8 equals 14. As you can see, the result of these additions is equal. This property can be observed in all APs, including reverse APs. For example, if you reverse the given AP, you get 12, 10, 8, 6, 4, 2. Now try adding the first and the last terms of this AP, that is 12 and 2. The sum is 14. Similarly, if you add the second term to the fifth term and the third term to the fourth term, the sum is 14. This shows a pattern that we can use to derive a formula for the sum of n terms. In a standard arithmetic sequence where A equals first term, D equals common difference, and n equals number of terms, the second term will be A plus D, and so on. In this way, you can compute each term till the nth term. Let the sum of these terms be S. Now, let's consider the reverse of this AP. In the reversed AP, the last term, A plus n minus 1 multiplied by D, appears in the first position, and the first term, A, in the last position. The sum of the terms of this AP also will be S. Now add the corresponding terms of both the APs, that is, first term to first term, second term to second term, and so on. While calculating, you will find that the sum of the corresponding terms are equal in every case. Thus, we get 2A plus n minus 1 multiplied by D in every case. As there are n terms, the total sum will be equal to n multiplied by 2A plus n minus 1 multiplied by D. As we are adding the two APs, the sum of n terms will be doubled, that is, it becomes 2S. So, to get S, that is the sum of n terms of an AP, you have to divide the equation by 2. Thus, you get the formula for S. S equals n divided by 2 multiplied by 2A plus n minus 1 multiplied by D. On further simplification, you get the sum of n terms in an AP. S equals n divided by 2 multiplied by the first term plus last term. Remember the Mason's problem? Using the formula for the sum of n terms, you can now determine the number of bricks to be ordered for the staircase. You can see that the number of bricks in the staircase forms an AP. According to the given data, the first step will have 4 bricks. Therefore, the first term A equals 4. Common difference D is 4, and the total number of steps in the staircase equals the number of terms in the progression, n, which is 25. You can apply the formula for sum of n terms to the given data. Substituting the values of n, A, and D in the formula, you get the value for the sum of n terms, S. After simplifying, you get S equals 1300. Therefore, the mason requires a total of 1300 bricks to construct a staircase of 25 steps.